Okay, today we are going to see this determination of the time response specification of the second order underdamped system for different damping factor. For this, we will see first 0.6 damping factor. The transfer function is given like this: 25 divided by s square plus 6x plus 25. So here standard format is omega n square divided by s square plus 2 zeta omega ns plus omega n square. So compare these two. Omega n square is like this, omega n you will get like this. So if you compare this and this, so you will get this damping ratio 6 by 10. So damping factor is 0.6. So theta we will find out tan inverse of root of 1 minus zeta square divided by zeta. So for this 0.92 you will get theta radians. Omega d will get as omega n into root of 1 minus zeta square is equals to 4 you will get. Okay, then we'll find out the rise time. Tr equals to pi minus theta by d. So pi minus 0.9. So here you got omega n into root of 1 minus zeta square. So you'll get the calculation 0.55 seconds. So the rise time you will get as 0.55 second. Peak time according to this formula you will get 0.785. Settling time, so according to this formula, so after substitution of zeta and omega n which you got here, you will get 1.33 seconds. Okay, so mp as e power minus pi zeta divided by root of 1 minus zeta square into 100%. So mp will get 51.61%, and the time response of t is equals to, you will get this function. Okay, note e is 2.718. So we will see the Matlab code. First numerator 0025, you can observe here there is no coefficient of s square and s, so it is only 0025. Then here denominator you can observe the coefficient of this is 1, this is 6, this is 25, so 1 6 25. So time, that is time vector, it is given as 0 in steps of 0.01 and total are 10. So we'll compute the plot, and here with the help of this figure, hold on, wn, what is wn is saying, just look at this, square root of denominator 1 comma 3. What is denominator is there? 1 comma 3 means this one and this one. So the square root of 1 into 25, that is what we are having here. That is, you can observe this line with this line, so you will get it. Then zeta, what is the value of zeta? Denominator of 1 comma 2. What is denominator of 1 comma 2? So it is 1 and 6. Okay, so divided by 2 omega n. So divided by 2 omega n, if you do this 6 by 10 you will get according to the calculation. So you can observe. Okay, so next system function, that is transfer function, is equals to, so this is what they have written, omega n square is equals to, so it is 1 comma 2, coefficient of this is 1 and the coefficient of this is 2. Then after that you can observe omega n square, that is this one. After that you can go for the theta. Theta is tan of a square root, so you can see here theta is nothing but tan inverse, so that's why that inverse is taken as a here, tan square root of 1 minus zeta square divided by zeta. So after that wd is equals to wn square root of 1 minus zeta square, so that wd is written here. Okay, so that is taken over here. Then after that rise time is taken with the help of this formula, pi minus theta by omega d. So pi minus theta by omega d. Then after that here taken as peak time, pi divided by d. Then settling time by this. Okay, so that is 4 divided by zeta omega n. Then after that mp is put like this. So here you can observe e power, e is replaced by 2.718. Then after that the same, all the values you can substitute here, whatever it is there according to here we have put. And step of system comma t we have written, system is this. Okay, then after that x label, y label. Then start writing the program like this. Okay, then here you can run the program. Initially I will give this clc, I can give clc, then run the program. So if you run the program, you will get this followed by, so this is a waveform. Okay, so first you can observe these values. What are the values which you got here? These values should match with your theoretical values. Look at this, this is a function we have given, system function. So that is what, the 25 divided by s square plus 6x plus 25, and you can observe the value of zeta 0.6 wn. Then after that theta, wd, rise time, peak time, settle time, mp. Then after that we'll see this waveform. You can observe the waveform. So you can observe rise time first. So you can observe the rise time here. So so I will take the help of this mouse. So at 0.5 there is a rise time from 10% to 90% of the final value. So that is up to here. So this point is 0.55 seconds according to this calculation. 0. Rise time 0.55 second. Okay, then after that what is peak time is this point. So this point is 0.7. This point which I kept the mouse is 0.785. that is the peak time. The overshoot has happened. Then after that the settling time is here, you can observe it is 1.33 seconds. So the 1.33 second is 1 is here, then after that so it is taking the settling time from here to the next part. Okay, so this is the Matlab code, theory part, design, as well as the explanation with respect to the time response of the second order system of underdamped system for damping factor 0.6. Like this you can change the transfer function and you can do the Matlab coding. Thank you. We'll see in the next video.